Hi, I'm Arnie Gunderson from Fairwinds Associates, and it's Sunday, April 3rd. A couple of videos ago, I talked to you about the types of radiation, and I talked about gamma rays, alpha particles, and beta particles. Well, there's one more type, and that's called a neutron, that I need to talk about today. When a uranium atom splits, it gives off two heavy pieces called daughter products, but it also gives off a couple of neutrons. Those neutrons hit the next uranium atom and cause it to split, and then we get a chain reaction. So when you see neutrons, that's an indication that a chain reaction is occurring inside a nuclear reactor. That's how you determine that it really is a chain reaction. Well, some data over the last couple of days and weeks have come up that indicate that one of the reactors at Fukushima may still be experiencing a chain reaction. First off, there was a report in one of the English-Japanese papers that discussed neutron bursts being detected about a mile away from the reactor. Now that got my curiosity because when I was a startup engineer back in 1974 on Millstone 2, we had neutron problems, and we were actually detecting neutrons at the guard shed at the fence boundary. So I know that nuclear reactors can emit neutrons, and they travel a long way. In and of itself, that report wasn't enough, and it was the only paper that covered it. Well, this week, a prestigious scientific paper came out, and it talked about the discovery of a strange isotope called chlorine-38. Chlorine-38 doesn't exist in nature, and it comes from chlorine-37 absorbing a neutron. Well, chlorine-37 is in seawater, and seawater is inside the nuclear reactors. So this paper postulated that we had a chain reaction going on in one of the Fukushima reactors, and it was turning salt water into chlorine-38. Again, it wasn't definitive. Well, on April 1st, TEPCO came out with its own report, and in it had a curious table. The table indicates that for Unit 1, there's an isotope called tellurium-129, and that isotope has a 70-minute half-life. Well, that can only exist if there had been a fission in the last half day, because it would have all decayed away otherwise. So the report indicated to me really quickly that, whoa, something's going on in Unit 1. And I read the report a little further down, and it also indicated high levels of iodine-131. In fact, the iodine levels in Unit 1 are 10 times higher than they are in Units 2 and 3. Now, if they all shut down at the same time, that can't happen. So where's the iodine coming from? Where's the tellurium coming from? Where's the chlorine coming from? And where did those neutron bursts come from? I think Unit 1 has a part of its reactor core that is still undergoing periodic nuclear fissions. We call that an inadvertent criticality, meaning we didn't really plan on this happening, but it is. Now, what that means is that, one, extra heat is being generated. Remember I talked about 95% of the heat came from fission and 5% from the daughter products? Well, if fission is occurring, there's a lot more heat in Unit 1 than just from its daughter products. The other thing is a lot more radiation, especially iodine, might be generated. And the last thing, and really the most important thing, is that a lot of neutrons are being generated. Neutrons are incredibly difficult to measure and could be exposing the personnel on that site to doses that they're not aware of. Well, I want to make clear what I am saying and what I'm not saying. I'm not saying that Unit 1 is running at full power, but what I am saying is that a portion of the core is periodically turning itself on without human intervention. How can that happen? Well, as they flood the reactor with water, the chain reaction begins. The chain reaction creates heat, boils off the water, and the chain reaction stops. They flood the reactor, chain reaction begins, boils off the water, stops. So it's possible that a portion of Unit 1's core is turning itself on and off and exposing personnel to neutrons that the dosimeters are not detecting. What this means for TEPCO is that they have to add boron to the water that's going into Unit 1 to stop that chain reaction from occurring. Well, thank you very much. If I hear any more, I will pass it on to you through these videos. Thanks.